Good morning students, this is your maths class. Today we are going to discuss the other topics of your chapter understanding shapes. The topic is transversal. So a line which intersect two or more given lines at different points is called a transversal. See in the example, these are two lines, line L and line M. So a line which intersect two or more given lines. So this line intersect these two lines. This is line T. This line T intersect these two lines at different point. One at this point and one at this point. So this line T is called a transversal. Here T is a transversal. Okay. If we have more than two lines, suppose this is line L, this is line M, and this is line N. So again a slant line which intersect these lines at different point. That slant line is called a transversal. So this is a slant line which intersect these three lines at different points. So this is a transversal P. Okay, here P is a transversal. So a transversal is a slanting line which intersect two or more given lines. Lines may be parallel or not. Okay. If the lines are not parallel, then in this case this slanting line is also called a transversal. Okay, because this line intersect these two lines at different point. So this is here T is a transversal. I think it is clear. Now your next topic is angles formed by a transversal to two lines. If we have two lines, line M and line N, then a transversal T intersect these two lines at different point A and at point B. So in this case, this transversal T makes many angles. Okay, this AT work as a ray on line M, and at this point these two rays meet each other. So here a angle is formed. Similarly here a angle is also formed, here also and here also. Similarly at this point again some angles are formed. So now we discuss in detail which kind of angles these are. Now students, you can see here we have two lines L and M and a transversal T. So this transversal T formed these angles at these lines. Okay, now we discuss in detail which kind of angles these are. So the first one is exterior angles. Okay, so those angles which are lying outside the lines L and M are called exterior angle. Means those angles which lie in the outside region, in the exterior region of line L and line M. Those angles are called exterior angles. See in this figure, angle 1 and angle 2 lying in the exterior region of this line L. Angle 7 and angle 8 lie in the exterior region of line M. Okay, this is your exterior region, this is also your exterior region. So these angles are called exterior angles. So the exterior angles, we have angle 1. This is the symbol of angle. So angle 1, angle 2, angle 7 and angle 8. These are the exterior angles. Next we have interior angles. So the opposite of exterior angles means those angles which lying in the inside region or in the interior region of the lines. See, this region is the interior region of line L and M. So those angles which lie in this interior region are called interior angles. Angle 3, angle 4, angle 5 and angle 6. These angles lie in this interior region. So these angles are called interior angles. So the interior angles, we have angle 3, angle 4, angle 5 and angle 6. Okay, these are the interior angles. Next is corresponding angles. So the angles on the same side of the transversal, but one is exterior or second is interior, then those angles are known as the corresponding angles. So the angles on the same side of the transversal, the angles on the same side of the transversal, but one is exterior or the second is interior, one is exterior or the second is interior, are called corresponding angles. Okay, so in this figure we have angle 1, angle 5, angle 2, angle 6, angle 4, angle 8 and angle 3, angle 7. These angles are on the same side of the transversal. Okay, angle 1, angle 4, angle 5 and angle 8. These angles lie on this same side of this transversal T. But among these angles, those angles which one is exterior or second one is interior are called corresponding angles. Same in this side, angle 2, 3, 6 and 7, these angles are on the same side of this transversal T. So angle 2 and angle 6, one is exterior or second is interior. Similarly angle 3 and angle 7, these angles are called corresponding angles. So the corresponding angles are angle 1 and angle 5, 1 and 5, angle 4 and angle 8, angle 4 and angle 8, angle 2 and angle 6, or angle 3 and angle 7. These are the corresponding angles. Okay, now there is a note that if the lines are parallel, means if line L and M both lines are parallel, this is the sign of parallel, then in this case these corresponding angles are equal. Okay, so there is a note that if the lines are parallel, means if line L is parallel to line M, then in this case these corresponding angles are equal. Means angle 1 equal to angle 5, angle 4 equals to angle 8, angle 2 equals to angle 6 and angle 3 equals to angle 7. Okay, now students, move on to the next angle. This is alternate angles. So now what are the alternate angles? The angles which are on the opposite side of the transversal but do not form a linear pair are called alternate angles. So in this example, angle 1 and angle 7, angle 2 and angle 8, these angles are on the opposite side of the transversal. Means if this angle is in this side, then the second angle is on the opposite side of this transversal. Similarly, as angle 2 is in this side, so angle 8 is in the opposite side of this transversal T. So these angles are called alternate angles. These angles are called alternate angles. Also angle 3 and angle 5, angle 4 and angle 6, these angles are also opposite, so these angles are also called alternate angles. Okay, angle 1 and angle 7, angle 2 and angle 8, angle 5 and angle 3, angle 4 and angle 6, angle 4 and angle 6, these are the alternate angles. Okay, similarly, if the lines are parallel, means line L is parallel to line M, then in this case, then these angles are also equal. If line L is parallel to line M, then in this case alternate angles are equal to each other. Angle 7 equals to angle 1, angle 4 equals to angle 6, or we can say angle 6 equals to angle 4, angle 2 equals to angle 8 and angle 5 equals to angle 3. Now move on to the next, it is types of alternate angles. Now we discuss how many types of alternate angles we have. So students, alternate angles are of two types. The first one is alternate interior angles and the second one is alternate exterior angles. Now we discuss what are alternate interior angles. So those interior angles which are alternate, okay, those interior angles which are alternate are called alternate interior angles. Okay, or we can say that the interior angles which are on the opposite side of the transversal and do not form a linear pair are called alternate interior angles. The interior angles which are on the opposite side, see, angle 3, 4, 5, 6 are the interior angles. So the interior angle which are on the opposite side of the transversal. Now angle 3 and angle 5 are opposite. Similarly, angle 4 and angle 6 are also opposite. So these angles are called alternate interior angles. Okay, these are angle 3 and angle 5, angle 4 and angle 6. Okay, so the second type is alternate exterior angles. Those angles, those exterior angles which are on the opposite side of the transversal. Okay, so the exterior angles we have angle 1 and 2 in this example, angle 7 and angle 8, but on the opposite side of the transversal. So angle 1 and angle 7, angle 2 and angle 8, these angles are on the opposite side of this transversal T. So these angles are called alternate exterior angles. Okay, and also these angles are not form a linear pair. Angle 1 and angle 7 doesn't form a linear pair. Okay, similarly angle 2 and angle 8 are not formed. So the angles are angle 1 and angle 7 or angle 2 and angle 8. Angle 2 and angle 8. These angles are alternate exterior angles. Now see, in this example we have to find alternate interior angles. So the definition definition of alternate interior angle is that those angles which lie in the interior region and also on the opposite side of the transversal. In this figure, angle X, Z, Y and W lie in the interior region of line L and M. And angle X or Y are on the opposite side of the transversal. If this angle X is in the left hand side of this transversal, then angle Y is in the right hand side of the transversal. And also this angle and this angle doesn't form a linear pair. Okay, we can't say that angle X and Z are the alternate interior angle, because these angles form a linear pair. Okay, that's why we say that those angles doesn't form a linear pair. So in this figure, angle X and angle Y, or angle Z and angle W, these are the alternate interior angles. Now we discuss alternate exterior angle with the help of this example. Now with the help of this example, we have to find alternate exterior angles. So the definition of alternate exterior angle is that those angles which lie in the exterior region of the lines and also on the opposite side of the transversal are called alternate exterior angles. In this figure, angle A, B, C and D, these angles lie in the exterior region of line L and line M. Okay, and on the opposite side we have angle A and C, or angle B and angle D. So these angles are called alternate exterior angles. Angle A and angle C, because angle A is in the right hand side of this transversal T, then angle C is on the left hand side of this transversal T. Similarly, angle B and angle D. Okay, these are the alternate exterior angles. Now I hope it is clear to all of you. So that's all for today. Thank you.